Hello students, I wanted to do just a few examples of doing the vector product, or otherwise known as the cross product, and looking at some of its properties and applications. It can be a little bit intimidating at first, but really just keep in mind that what you're doing is finding a third vector that is normal, that is perpendicular to both of the original vectors. The other thing is there is a way you can do it with a matrix and finding the determinant of a matrix, or you can just look up the formula. And so I will just be using the algebraic definition. It's in your textbook. So practice just using that. So for problem 1a, to find the vector product, we're going to take A and write it as a column. I guess you don't need to really rewrite it. You can just read it sideways. But it's 2, 3, -5. And then B is 1, -2, and 3. And so when we cross those, you get a new vector where the first component is A2B3. So 3 times 3 minus A3B2. So A3 is -5 times B2 is -2. Sorry, my stylus is not writing very well today. Then I go A3B1 minus A1B3. So A3B1 minus A1B3. 2 times 3. Why are you not working? And then A1B2 minus A2B1. So A1, B2 minus A2, B1. Okay, great. So notice that each of the components of your cross product depends on the other two components of your original vectors A and B. And that's how we end up with something that's perpendicular. And so the first one becomes 9 minus 10. The second component becomes -5 minus 6. And the third component becomes -4 minus 3. And so altogether, we get a new one. I'll bring it over here. We get a new vector that is -1, -11, and -7. So that equals A cross B. Now, what we should check is that this new vector really is normal to our original other vectors. And the way you check normality is by taking the dot product, the scalar product. And so I'm going to just take A cross B dotted with A. And so if we do the dot with A, we have -1, -11, -7, dot 2, 3, -5. And that gives us -2 minus 33 plus 35. That equals 0. So we know that we have a vector that is normal to A. Now let's try the cross A cross B dotted with B, 1, -2, 3. And then we end up with -1 plus 22 minus 21. That also equals 0. So I feel pretty confident with our answer because we found a vector that is normal to both A and B. And that is what the cross product does for you.